Hey everyone, it's Miss Brooks with your Daily Dose of Math. Today we're going to be starting Chapter 7, Section 1, Adding and Subtracting Polynomials. But before we can actually begin to add and subtract polynomials, we need to know a lot of the definitions that go with polynomials. So today's lesson is a lot of definitions. So let's get started by learning about what monomials are. So our first section talks about monomials and polynomials. The first thing I want to discuss is monomials. So in our note packet it says, in some cases you can model a situation with an expression composed of monomials. A monomial is a real number, a variable, or a product of a real number and one or more variables with whole number exponents. So some examples of monomials would be just the number 18, the variable z, negative 4x squared, that is a combination of a number and a variable, 2.5xy to the third, a fraction, a over 3, which could also be written as 1/3 a. It's important to know that a over 3 and 1/3 a are equivalent to each other. Now, we take these monomials and we add and subtract them together to make larger expressions called polynomials. Polynomials are when we start doing the addition and subtraction, although we can just add and subtract monomials. Now, what we're first going to take a look at are degrees of monomials. Now, this is a very important statement. We have the degree of a monomial is the sum of the exponents of its variables. If no variable is present, you have any number that is not 0, then the degree of a non-zero constant, and that's any number that's not 0, is 0 because there is no variable present. If you are ever asked to find the degree of 0, 0 has no degree. So the first thing we're going to take a look at is finding the degree of monomials. If there are variables, it's just the sum of the exponents. If there is no variable and the number is not 0, the degree is 0. If the number is 0, then there is no degree. So these three sentences are going to be vital to this first section. So in our first problem, we want to find the degree of some different monomials. So in part A, we want to find the degree of 5x. 5x, what I want to do, there is a variable. My degree is whatever the exponent of the variable is. In this case, 5x, my exponent on x would be 1 because I only see one x. So my degree of 5x would be 1 because that is the exponent of my variable. In B, we have 6x cubed, y squared. When you have more than one variable and you want to find the degree, you're going to add the exponents of the variables together. In this case, I need to add the 3 and the 2 because those are the exponents on my variables. 3 plus 2 makes 5. So the degree of 6x cubed, y squared is 5. Lastly, we want to find the degree of 4. 4 does not have a variable with it, and it is not the number 0. So anytime you're given a number that is not 0, the degree is 0 because there is no variable present. The only time it's no degree is if the number was 0, but in this case the number was 4. So finding your degree of a monomial, you are just looking at the exponents of your variables. At this time, I would like you to try number 2, A, B, and C. And when you have completely finished the notes, I would like you to hand it in for Miss Brooks to check. In our next problem, we're going to actually add and subtract monomials. Monomials are added and subtracted by combining like terms. So we're looking for things that have the exact same variables. So let's take a look at number 1, part A. we want to find the sum of 3x squared plus 5x squared. So these two monomials would be like terms because they both have a variable of x squared. So when I add these together, I'm only going to add the coefficients, the big numbers on the outside. 3 and 5 makes 8. And then I'm going to keep the variable and whatever exponent it had the same. So 3x squared plus 5x squared would be 8x squared. This is a monomial with degree 2. If we look at part B, 5x cubed y minus x cubed y. We can subtract these as long as they are like terms. So again, like terms means they have the exact same variables. So the first one has x cubed y, and the second term has x cubed y. So since the variables are exactly the same, I'm going to combine the coefficients and figure out what the result is. So 5x cubed y minus 1x cubed y. Remember, if you don't see a coefficient, that means it's 1. So we're going to combine those coefficients. 5 minus 1 is 4. The variable is going to stay exactly the same, x cubed y. We do not change the variables. We are only changing the coefficients when we add or subtract. So 4x cubed y is a monomial that would have a degree of 4 because I have two exponents, 3 and 1. At this time, I would like you to try number 2 and number 3 from this same problem. Find the sum and find the difference of those monomials listed. Now, the last part of what we're going to look at today are polynomials. So polynomials are just bigger versions of monomials. It is when monomials are added or subtracted together. So a polynomial is a monomial or the sum or difference of two or more monomials, which we call terms. Now, when we talk about polynomials, we can name them based on their degree, which again is your exponents of your variables, or we can name them based on how many terms they have. So these two charts we have here are going to be very crucial to these next types of problems we do. We have to know what degree and what terms are we talking about for the polynomials. So when we talk degree of a polynomial, the degree of a polynomial, since it's typically more than one thing, is going to be the greatest degree of any term you have. So it is very important that we pay attention to our exponents when we're looking at polynomials. The other way we're going to name them is based on how many terms they have. So we need to look to see, do they have 1, 2, 3, 4 or more terms, so we know exactly how to name it. So one process that we're going to use to help us name these correctly is writing our polynomials in something called standard form. So standard form, the last definition that we want to talk about today, is when a polynomial is written with the exponents in descending order according to their degree. In other words, we write them from the highest exponent to the lowest exponent. And you can see that in the example written, we have 6x to the 4th minus x cubed minus 3x squared plus 7x minus 5. The highest exponent was 4, so it was written first, and then it stemmed all the way down to your constant. So standard form, highest to lowest exponent, and once it's in standard form, it makes it quite easier to classify based on its degree and on its amount of terms. So let's take a look at two examples of how to write in standard form and classify the polynomials that we're working with. So in problem 3, we're going to classify our polynomials after we write them in standard form. So number 1A, we want to write the polynomial in standard form and then classify it based on degree and number of terms. We need two names to classify this. So in A, we've got 3x plus 4x squared. First thing I want to do is write it in standard form. So standard form means write your highest exponent first, in this case 4x squared, and then your next highest exponent. Well, the only thing I have left in this problem is 3x. So this would be plus 3x because it was a positive 3x. So I'm just rearranging my terms to put them from the highest to the lowest exponent. Once I've put them in this order, then I can name it. First, I'm going to name it by its degree. My highest degree is a 2. That's my highest exponent. So if we look at our degrees, a 2 is named a quadratic. So this one, based on its degree, is a quadratic. Anything that the highest exponent is a 2 are quadratics. And how many terms do we have? 2 of them, 4x squared and 3x. So if I name this based on the number of terms, there's 2 terms, so this would be called a binomial. So 4x squared plus 3x would be known as a quadratic binomial. Now these charts you are going to want to memorize. You need to know constant, linear, quadratic, cubic, monomial, binomial, trinomial, and polynomial. So right now use them as your reference, but you are going to want to know which degrees and terms give you which type of classification. Now for part B, 4x minus 1 plus 5x cubed plus 7x. The first thing we're going to do is write this in standard form. So again, standard form means write the highest exponent first. In this case, that would be 5x cubed. It is positive, so I'm going to write 5x cubed. And then I want to write my next lowest exponent, and then my next, and then my next. So I go in descending order. So I have 4x, negative 1, and 7x left. So 7x and 4x would come next. And I'm actually going to go ahead and combine those because they are like terms. They both just have an x. 4 and 7 would make this 11x. And then lastly would come that constant, which would be minus 1. So 5x cubed plus 11x minus 1. If we classify this, the first thing is its degree. It has a highest exponent of 3. Anything with a high exponent of 3 is called a cubic. So this would be cubic. And how many terms did it have? 1, 2, 3 terms. So 3 terms would make this a trinomial. So 5x cubed plus 11x minus 1 would be known as a cubic trinomial. Now you try number 2 on that same problem. When you have fully completed the notes and done all of your U-tries, turn your packet into Miss Brooks so she can check your work for today. This concludes our lesson on being able to understand monomials and polynomial classifications. If you have any questions, please ask Miss Brooks. Otherwise, we'll catch you next time on your Daily Dose of Math with Miss Brooks.